Watch the complete playlist on the app Pions. Download the app now.
A cell of EMF 1.1 volt. So EMF of the cell here is 1.1 volt. Internal resistance of this cell is 0.5 ohm. Is connected to a wire of external resistance R as 0.5 ohm. Correct? Okay, fine. Another cell of the same EMF, let's call it as E1, R1, E2 of the same EMF means 1.1 volt, is connected in series. Okay, series to whom? To the previous circuit. But the current in the wire remains the same. So be very careful. We will take this scenario later on. We have to find the internal resistance of the second cell. We will consider this. But first, let's simplify the first part. So we have a battery, okay, with an EMF 1.1 volt, internal resistance 0.5 and external resistance 0.5. Correct? This is the scenario. Now, what is the current flowing in this whole circuit? Simple. I is equals to E upon R plus R. We have seen that, right? So E is nothing but how much? 1 volt, and R plus R 0.5 plus 0.5 1. So what is the current here? So here it is 1.1. Sorry, my mistake. Let me make it 1.1 volt. So 1.1 divided by 1, which is 1.1 ampere. That's the current flowing in the first circuit. Now the question says another cell of the same EMF is connected in series with this circuit, but the current still remains same. So what should be the value of small r? Correct? So let's try to draw it again. We have an external resistance here, 0.5, and we have here a battery voltage, which is 1.1 volt. Correct? This is our battery voltage. And another one, that is again a battery 1.1 in series, because they are saying specifically, okay, connected in EMF is connected in series. If it is in series, so we are connecting negative with positive terminal, and internal resistance of this one is 0.5. So we can do one thing, we can simply make here a small resistance for the first one and small resistance for the second one. This is 0.5, this is unknown R. Done. Here we know the circuit has a current I, which is equals to 1.1 ampere as per the question. The only difference between the first case and the second case is you have an extra battery here. So what is the new total voltage in the circuit? The total voltage in the circuit will be, we know that they are connected with negative to positive. So they are in series 1.1 plus 1.1. This is the total voltage applied, which is 2.2 volt, correct? And what is the total resistance? The total resistance, let's call it as capital R, that will be equals to 0.5 plus R plus 0.5. So what is the total new resistance? 1 plus R. So if this is the new battery voltage and this is the new total resistance, what will be the new current? E upon this capital R, correct? Here the capital, be very careful, I am being very specific, this capital R is not same as this R. Or let me just take it as R equivalent just to avoid that confusion, right? E upon R equivalent. Here R equivalent was R plus R. As per the diagram, here R equivalent is this thing. So what is E? 2.2 volt upon R equivalent 1 plus R. Now what is current I? Current I is nothing but 1.1, as they have said, equals to 2.2 upon 1 plus R. Clear? Now when you cross multiply, this implies 1 plus R equals to 2.2 divided by 1.1. 11 and 11 twos are 22. So point remove and you left with 2, and R will be equals to 1 ohm. Done.
Watch the complete playlist on the app Pions. Download the app now.